In previous videos I've represented vectors on squared paper. Here just plain paper. What I have here, capital letters A, B and C. Let's say this point A could represent a town, Aberystwyth, that one there, B for Birmingham, and Cambridge is a little bit further to the east. That's Cambridge there, Aberystwyth, Birmingham, Cambridge. And here's a road, just an imaginary road, linking Aberystwyth to Birmingham. There's the road, and we represent that by this little A over here. And then there's another road linking Birmingham to Cambridge. Okay, imaginary road, straight line, and we represent it as that there. So then, how would we write this one here, A to C? I want to know the name of the vector from A to C. There it is, from A to C. But I want to write that in terms of little a, little b. How do I do that then? Remember, to get from Aberdeen to Birmingham, Birmingham to Cambridge, that's the long route, and the quick route is here. The resultant route, or the resultant vector, A to C, that's the quick way. So I want to know the quick way in terms of A and B. So here we go. To get from A to C, the long way, go from here to here, that's represented as that. And then from here to here, follow the arrow, it's represented as little b. There you go. So A to C is represented as A plus B. I'm going to introduce a fourth letter, capital letter here. I'll call this one over here D. D for Doncaster. Okay, it's not a very accurate map, just represent it. And let's just say C to D, just pretend C to D is parallel to A to B. So A to B, C to D are parallel, running the same direction. And then from B to D, Birmingham to Doncaster, let's say that happens to be parallel to A to C, same direction, like that. So then how would I represent C to D in terms of these two letters here? What I would do is, remember we're in C to D. Remember that there and there is the same size, same direction. Now you know in a previous video, if they're the same size, same direction, they're the same vectors. That vector there is identical to that vector. So we just represent it as that. C to D is same as A to B. So little a, there you go. Right, I don't really want to put the arrows here. I'm just going to take these arrows off for now. Just pretend those arrows are not there. Now, how would I represent, let's say, going from not A to B, but from B to A, going backwards? To get from B to A, we're going in the opposite of the established direction. That arrow there was already given in the question. So to get from B to A, we're going in the opposite direction of the arrow. So we're going to write minus A, like that. And similarly, if you want to go from C to B, Cambridge to Birmingham, going that way, all right, we're going in the opposite direction of the arrow that was given to us originally in the question. That'll be minus B. And similarly, from D to C, think about this. We know C to D already is A, but to get from D to C, we're going in the opposite direction of this one here. So it'll be minus A. Remember, that's A, positive A, and that one there, therefore going in the opposite direction, minus A, same size though. how would we write B to D then? B to D, Birmingham to Doncaster. Well, you know that line there is the same size as that. It's a parallelogram. That and that are the same size. To get from B to D, it's got something to do with going from A to C. Well, we know A to C there, look, A to C is that. And then B to D is in the same direction as A to C. Look, B to D is the same direction as A to C. And it's the same size. So guess what? You just copy that and put that over here. That's the answer. But just to make it a bit more complicated, if I wanted to go from D to B instead, in the opposite direction, I'd have to put a negative in front of all of that. That could be simplified as negative wins. There you go. Now what if I introduced another letter? I've used D, I'll call that one E. Right, straight line, right, A, B, E are on a straight line. Now let me just tell you this, B to E is the same size as A to B. So in effect, going from A to E is double the size, right? I've just made that A to B double, twice as big. So how would I represent A to E then? From here to here. It's not going to be called A. Yes, it's the same direction. A to E is the same direction as that, but it's twice as big. So you'd write 2A. And likewise, if you want to go from E to A backwards, it'll be called minus 2A. Right, let's make this a bit more interesting. I want to know this one here. I want to go from E to C. So how would I write that in terms of little a and little b? I start at E and I'm going to finish at C. Right, obviously that's a quick way, but the long route, follow my finger, go this way, and then you end up over here. That's the long route. So let's see what this is. To get from here to here, that's going to be minus 2a. Remember that's 2. Remember all of that was 2a, but we're going in the opposite direction. That would be minus 2a. Look, put it down over here. E to A is minus 2a. And then from A to C, our final destination was A to C. There it is. A plus all of that. So we add on, we're adding on all of that. Now we can simplify that, collecting like terms. Minus 2a add 1a, and the number line is minus 1a. And then you just got the plus b by itself. So E to C is that there, that's the answer. Now you could write that in a slightly different way. If you don't like having negatives to begin with, you can swap the letters around. You can put the b first and then stick the minus a at the end. Now there is a quicker way to get from E to C. You can go from E to B and then B to C. From here to here. Let's just write that down. From E to B, followed by B to C. That would complete the journey. So what is E to B? E to B, well, it's in the opposite direction. Remember, from B to E, from here to here is just A. It's just a duplication of that. From B to E is just positive A. So from E to B is going to be minus A. And then B to C, simply plus B. Right, you can swap these around so you don't have a negative in front at the beginning. But that, isn't that the same as that?